Yes, friend or foe. Okay. This is part morality tale, part crisis. But we're going to wend our way into this. This is a multi-part sort of talk. Some parts are going to be actually technically useful to you. Some of it is going to seem like paranoia. But in the end, we'll see who wins. Okay. Work, you piece of... Okay. Here's the dilemma. Space is cheap. You all know that. You all know that. And your average user, mimicking someone from Star Trek, whose name I forget, will say something like, roughly along the lines of, I need space to make me go. Now, of course, once they have the space, they will want to do research or problems that use lots of space. It's ironic that the space rarely gets unused, even though they never had to have it before. And of course, once they use all their space, they need more space. This is what we technically call an open loop with no feedback. It all began innocently enough. This is a 9-month life in the price of a 500 gigabyte drive. I'm not going to belabor this because you've seen pretty graphs like this before. They start off at some reasonable level, enough to discourage casual space eaters, but eventually it drops. Yeah, 750s over this time an 18-month period, and again the same depressing trend. Cheaper and cheaper. And for 1,000 gigabyte drives, or as we sometimes call them, terabytes, this is only 2 weeks old, but again, you can see the depressing trend starting again. I should have said the three colors are high price, medium price, and low price. The real problem is that people say, well, you know, it's only $200 for a terabyte, can't I have a couple? So we have desktops. These desktops have, you know, nowadays it's not really uncommon to have anywhere between 500 and 2,000 gigabytes of space on a desktop. Now, you know, apart from porn and network TV shows, it's hard to understand what they're doing with that amount of stuff there, but nevertheless, there are real problems there. How do you mount these as file systems? Do you really want to have a terabyte ext3 file system? Do you really want to spend 45 minutes FSCKing it should something go wrong? And if you don't, suddenly you have, you know, say you pick 300 gigabytes as your size. Now you start having boatloads of file systems. Most users don't want boatloads of file systems. You know, it's just an issue. And you know, the average user, which hitherto had just said, well, just use up the rest of my disk for my data, now has to worry about multiple disks, multiple partitions. You start worrying about size limitations of older versions of Linux or of Windows. You know, can they handle 5 terabyte file systems, so forth. How do you back it up? Let me tell you, the first time you try to back up a terabyte file system on CD-ROMs is the last time you do it. Even trained gerbils will not help. So you then go to exotic DVD RAM backup, and you find that's both expensive and slow. The best of all worlds. Now, of course, you could be clever and dump it over a network, and that's a good solution in some places. I'm recalling the last time when we do our dumps on our systems, we have a 250 gigabyte home directory. It takes 2.5 days real time to dump that. This is what we technically call a problem. Incremental dumps are, of course, way faster, but a full dump is nevertheless very slow. To my mind, these are just insoluble problems. I know how I would fix them, although that may not work in your case. But you know, generally, I err on the side of saying, well, we're only going to back up 50 gigabytes, and the rest is your problem. If that doesn't work, well, we'll talk a little bit more about that later. Come on, you can do it. Yeah. The server case is approximately the same, except there's the opportunity to have a lot more storage. Servers, your average desktop probably is most happy with 1, 2, or 3 drives. Some servers are proudly advertised that they can take 14 drives. Some, like Thumper, isn't it Thumper? I think so. The Sun Thing takes 42 drives. You'll notice this is just more of the same problem. And unlike desktops, most people would take the opportunity with servers to pound the disk. And when I say pound, you may not pound them as hard as I do, but nevertheless you will pound them. And this just aggravates wear and tear on the disk. Disks are fragile things. Typically it takes me a month to kill is an LD10 for my disks. In a month I will kill 10% of my disks. So now you may be more lenient on your disk than I am, but still I point out that this is fragility. And unless you're very keen on pulling your server out and changing disks, you might want to go to something more useful like RAID systems, which are far more tolerant of both the disk failing and easing the path to actually changing it. I don't actually want to spend a lot of time on backup. Backup is a full topic in and of itself. There is a Sage booklet on backup by Curtis Preston. There'll undoubtedly be a backup off here at Lisa, although I don't recall seeing it advertised, but I feel there always has been one. The only things that I think large size bring to the table, users have to be very much more aware of the difference between backup systems and archive systems. That is to say, are we just putting this away so that we can delete it? But I want to be able to get to it sometime, but it's not like I have to have it on immediate recall. You want to think a lot more about indexing stuff. If you have 1,000 terabytes, sorry, a terabyte, 1,000 terabytes is a lot. If you have a terabyte's worth of stuff and they're all 20 kilobyte files, you want to think about that a little. You may want to think about how you're going to index that. It's not so bad if the things that you're storing are a lot bigger size, like of the order of 100 megabytes. Another thing that can help you greatly is try and segregate the data by backup policy. I know this runs contrary to the theory that the customer is always right, do what they want, but you will generally find life easier if you have a file system which is backed up, which contains modest-sized files, and then large data holding areas where you put the stuff that doesn't get backed up. And those you might archive or something like that, but it's not clear you really want to run incremental backup over multiple terabytes on these things. Most of the time, the wrong thing will happen. You also want to look hard at the trade-off between storing these large files and the cost of regenerating them. If it's only going to be modestly expensive to regenerate them, then don't back them up. What the hell, If you lose them, just recompute them or, whatever. Obviously, that doesn't work for some stuff, but it works for a surprising amount. I've had a lot of people actually, come to me and say, we need to store this, n 100 gigabytes of stuff. And I said, well, how long would it take you to recompute it? 4 hours. And it's like, geez, it takes a lot longer than that to stream the stuff off and off tape. So in that case, you just want to think about that as an alternative. And without a doubt, if your backup system doesn't offer it, then scrap it or put a shell around it. I think you have to demand verification that what you got back was what you put there. We'll talk about this more later, but this is a serious issue. And when you start talking about volumes of the order of terabytes, you will see uncorrectable errors. You will get errors that get through the OS that are undetected, and it's your fault. It's your lookout, it's your responsibility. You need to have some way of getting verification. I'm not particularly fond of, I don't want to spend a lot of time on this either. I think it's actually always problematic about how you want to use this space. Frankly, making it all available as NFS has its own issues. Again, most OSs sort of have problems with exported volumes and size issues. But you know, if you want to make it available as NFS, that's fine, or as file systems. There are quite a lot of issues to do with network connectivity, and again, I don't want to go into detail here because it's very sort of site-specific. You might think that, for example, that you can use connectivity in the form of iSCSI. It's a very sort of flexible arrangement where you stick storage somewhere and make it available anywhere that IP goes. Your mileage may vary. That actually applies to the whole talk. Your mileage may vary, but I've given up on iSCSI. Too many errors, too many silent errors with no indication that anything went wrong, except for the fact my checksumming caught it. So I've given up on that, but a lot of people have luck with iSCSI, so who am I to say? But even if you use Fiber Channel Connect and go through Fiber Channel switches, again, these are very site-specific. I prefer the idea of Fiber Channel myself, but there are other alternatives out there. And I will actually point out that once you have a fair bit of disk, you're going to have to learn what IBMers learnt in the 50s and 60s, forgot in the 70s, rediscovered in the 80s. People wrote papers on it in the 90s. And that basically all I/O is about managing heads on disks. That's all there is to it. You just got to manage the heads. You've got to make sure that you don't have two people trying to access the same disk at the same time as much as you can. And just be aware that if you want to get more I/O bandwidth, you have to have more heads, which runs against the fact that you have large drives. This is a complicated subject, and again, I can't do it justice in the context of this talk, but I will warn you, if you have a lot of disk, you actually have to pay attention to how you're designing the I/O and designing access to the I/O. It's quite a complicated thing. And I just don't want you to think that you can just sort of like daisy chain 2 petabytes worth of RAIDs together and get anything more than 30 megabytes a second out of it. And if you do, you will be grossly disappointed. Now, I want to put this in the context of something, so I want to give you a hypothetical example where we will walk through some of the issues that are going on. Imagine you want to do TiVo, and I assume everyone here is roughly familiar with TiVo, even if you don't have one. It's a very easy access to a VCR-like interface. But the problem is that you have to plan ahead. You don't have to plan ahead a lot, but you have to plan ahead. So imagine that we wanted to fix that. And the way we're going to fix it is we're going to record everything all the time. And now the whole thing about watching TV is a navigation problem. It's all there. You can just go look for it. Now, you know, why doesn't everyone do this? Well, it takes a little bit of space. So a standard definition channel runs you 43 gigabytes a day, or 16 terabytes a year. And high definition channel, these numbers are always subject to change, of course. They're all involved about whether using MPEG-2 encoders or MPEG-4 and yada, yada, yada. But, you know, take these as sample numbers. It's all a hypothetical example anyway. So imagine if we had then a standard cable setup where we had 65 standard definition channels and, say, 10 HD channels. You can sort of see this is going to come to about 1,600 terabytes a year, which is, you know, a fair bit. So, now I would want to point out that this is like the old fire hose story. It's we'll call it 1.7 petabytes. It's 17 petabytes per year every year. It just doesn't stop after 1 year. If you're going to do this for 10 years, that's 17 petabytes. Furthermore, you hope you don't get a lot more channels. That will upset things. And we know this won't fit in a desktop even yet. So how are we going to do this? Well, that's an interesting question. The question is, how do you think of disk? You can't get away with thinking about single, terabyte drives. So the way that most people might think about this to start with is your standard tier 2 or tier 3 RAID unit. And by this I mean your generic sort of Nexan or Western Scientific or, you pick a brand. These typically come 3U high or 4U high. They have 10, 12, 8 terabytes in them. or as I like to think of them, 2 to 4 terabytes per U. And you start thinking about storage in odd ways when you start thinking about it in bulk. And roughly $1,000 to $1,500 a terabyte. Now, those are raw numbers. After this, I'm going to be talking about proper numbers, but that's sort of the raw number that you might think of. Now, the problem with that is this means you're buying like 133 RAIDs a year, which is like a pain in the ass, I have to tell you. You've got to pack them, install them, manage them, look after them, connect them to fiber channel switches or not. Yeah, it's what we technically call a pain in the ass. Now, so you think, well, okay, let's try something a little bit different. And by this, I'm going to use a Sun 6140. This is not to say I'm advocating a Sun 6140. It's a hypothetical example. This is a, you can think of it as roughly a 100 terabyte RAID that occupies a rack. And the numbers I'm going to use here are actually actual capacity things as reflected in file systems. That is to say, it now takes into account the fact that you have global spares, that you're using RAID 5 with parity disks and the overhead that the operating system puts on it and yada yada. And so now the cost is $1,800 a terabyte, which is pretty respectable. What's more important, it's about 16 terabytes a square foot. And there will be a test on this as you leave. Now, what more importantly, I don't know how space in your machine room goes, but this is 27 feet of aisle space per year. And, we don't have 27 feet of spare space in our machine room at all. So there's sort of an issue there. Luckily, the power and cooling is not so much of an issue. These things still draw way less current and generate way less heat than, say, a rack of CPU servers. And you can actually go to other options such as, I believe it's called MAID, which is sort of RAID systems where they spin the disk down. They do some statistical modeling of how many disks actually need to be upped in order to serve you your data. So there are ways of cutting them, powering and cooling. So this is a fair bit of machine room space that you can require. And actually, in our environment, and it's true for other people as well, machine room space is probably the most stringent bottleneck that you actually have for this sort of stuff. Now, that's a problem. But as with all problems, it's an inducement to actually be clever and do something fun. So the question is, can we reduce that at all? What are the access patterns? So let's sort of think about the problem. If you're thinking about looking at TV, yeah, probably nearly all the requests are going to be for programs in the last month. You're always going to want to look at old ones, but not too often. So the question is, can we actually shrink that down? But if you're going to shrink down the number of disks, where are you going to put all the old stuff? That's right. As with all storage talks, it always gets back to tape. There's no avoiding it. Now, I will say that modern tape is not your father's tape, nor your grandmother's tape. These things are actually fairly serious units these days. Modern LTO4, which has been on the market for nearly a year, they have an 800 gigabyte cartridge. They're $80. Each drive can do 120 megabytes sustained I/O. I've not actually verified that, but I will soon, but I believe that number. And in a reasonably good library, it's 60 seconds access to access any block on any tape in the library, which is not too bad. So these things are cool. You think you might be able to make this go. You'll notice that at $80 a cartridge, it's only 10 cents a gigabyte, which is pretty darn cheap. Libraries, similarly, if you want to talk about the cost and size of libraries, there's roughly two parameters, the number of drives and the number of slots, or the capacity. Assuming that the number of drives is modest, because we probably don't need too many. And again, I'm going to give you a hypothetical case here. If we had a 2.5 petabyte Sun library, it costs you $172 a terabyte, and you get a density of 41 terabytes per square feet, which is actually pretty good and a lot better than the disk. The thing that's cool about that is if you need to make this library a little bit bigger, it becomes staggeringly cheap. You're now talking about a cost of $7 a terabyte, which is amazingly cheap, and you get a density of close to 80 terabytes per square feet. Now again, I just want to emphasize the fact that machine room space is just really expensive and scarce, and this is the only way I know to get serious density out there on the machine room floor. But 80 terabytes a square foot is pretty darn good. So this leads you to a two-level architecture where you have something the order of 200 to a petabyte worth of cache. Now that's something you really want to wrap your lips around. I love the idea of saying I have 400 terabytes of cache sitting in front of a large tape library. And now you can start being inventive about these things. You could keep everything for a month. You could keep the first 5 minutes of every show for 5 years. Now why would you do that? Well, in 5 minutes, you could go off and get the rest of the show from the library. And so the user, I'm told in some industries this doesn't work, but on the whole, you could play the 5 minutes you've kept on disk while you go off and get it, and then you splice it in, and then the user thinks that it was all there on demand, with just a second or two access. As it turns out, there are other usage or access patterns, say in the adult film business, where there's a different kind of usage pattern. But on the whole, this just seems like a fine idea. And in the case where someone's looking at something that's over 5 years old, you just say, you don't have to wait 5 minutes. That doesn't seem such a bad thing. All is rosy now, but now I'm going to have to tell you some bad things. When you really use disks, when you really use networks, when you really use tape, well, I haven't seen it with tape yet, but I still think I will, things go bad. And I'm sorry if this is the first time you've ever heard this, but you don't always get back what you put there. Now, I've been doing this for a while, and I've learnt to check the answers. Let me give you some examples. In the mid-1980s, I had a colleague, the File Motel, sorry. The File Motel, this was not the case that Bill was referring to, but when I originally wrote the File Motel, which is my first backup system, it ran over Peter Weinberg's network file system. Everything was cool. Except, the thing I did was I kept a path name and a checksum, and I checked them. And I noticed after a month or so that things weren't working. I was getting in lots of files and they all had the wrong checksums. And I was like, anyway, bottom line is, it came down to the fact that the local area network we were using, whose name shall remain nameless, there was in fact a flaw in the KMC 11Z driver, such that with a certain race condition, the 32-bit buffer of data would get accessed before the data got there. So the trailing bytes, a variable number of them, came out as zeros. And, and I felt PO'd here because why was I seeing this and no one else was seeing it? Well, it turns out everyone else was seeing it, they just never noticed. I was the only one to I was the first one to check. And and that was an epiphany to me. It's just because everyone else says they don't see a problem, doesn't mean there isn't one. So in the early 90s, I was helping a colleague out. I was doing, strangely, a file system, ISO file system standard, where I was insisting on the use of checksums in various places. And a colleague said, I have this thing where I checksum all my files and I check them every night, and he was getting collisions. And it turns out he was using a 16-bit checksum and he had 10,000 files, so actually you kind of expect that. So, I helped him out, and I said, well, why the hell are you doing this? And he says, well, I like all my files, I checksum them every night, and when I notice a file changes its checksum, I just get it off backup and get replaced. And I was thinking about this, and I was thinking, well, that's failing some invariant rule that I would like to hold for computers. And I asked him how often it happened. He said once or twice a year. So he was someone who had actually been gathering data for a little while about essentially neutron decay sort of events, cosmic rays suddenly causing bits to flip in a disk. Now, he never investigated how they were different or why or anything like that. He just replaced them. It was actually a good pragmatic decision. This sort of perturbed me, but I'd already decided I didn't like anything anyway, didn't trust anything anyway. So when in the very late 90s, when I was pounding upon one of the first Sun E10Ks in the country, we started seeing errors. And again, we had sort of self-correcting, self-detecting error stuff. And we found that we were getting an error in the Sun RAID systems of roughly 1 sector per 40 terabytes of I/O. Now, of course, for most sites, that's 1 per year, and they wouldn't have noticed. But for us, that was every 3 days at that point. So we were noticing. And to Sun's credit, they found the problem a year later. And we'd sort of found our way around the problem in that we checked. You don't want to hear about how we checked, or maybe you do. We actually, every 256 kilobytes of I/O, I calculated a checksum, and when you wrote a file, you generated a file of checksums for every 256 kilobytes. We then, as we closed the file, we immediately reopened it and re-read in all the checksums and verified all the checksums. If it didn't work, the program did an exit 1, and it went off and did it again until it worked. And, and that was a fine thing. Finally, in our Ngawi system, which I've talked about previously here, we have a lot of one-use servers with lots of disk in them. In fact, we're using freeware cards, RAID cards, to connect them to. And we noticed that there was quite a lot of spurious or bad copies being made. And we eventually tracked it down to the fact that that version of the freeware cards required active termination on the riser card. No one sort of knew this, was willing to say it, but we observed when we got the riser cards from freeware that solved the problem, they had active termination. And the thing that was bizarre about this was the only way to tell if the problem was there or not was to just randomly copy stuff for 10 minutes and see how many checksum errors you got. With active termination, we got done. With any other form of termination, you had anywhere between 5 and 20% errors. Now, again, there's nothing in any of the logs. All the drivers are happy. No one's detecting any errors. The freeware was fine. It's sort of bizarre. This is why I'm always very wary of things computed on this. So I think it's fair to say that you should trust no one. Everything in a computer is out to get you. And the only way I know to combat this is as early as you can, computer checksum for a file, and check that damn thing every time you do anything to it. And even if you do nothing to it, check it anyway, every now and then. Now, you may think this is paranoid, and yes, it is. I will point out, though, that in a certain application we have where we're extracting MPEG files off tuner cards, I generate the checksum for the MPEG fragment that we generate and put it in the file name. And it gets checked every damn way along the way to wherever it goes to. So, end-to-end checking is the right thing to do. Now, as part of this, I've actually become a lot more laissez-faire about checking any individual steps. Copy something to somewhere, I don't even bother looking at the error return anymore. I mean, why bother? If it says there's an error, fine, something else will pick it up. If it says there's not an error, there might have been anyway. So there seems to be no point checking. Now, you can check if you like, because it helps with error detection, but on the whole, don't believe anything any individual step says. Check things at the very end. Particularly true of disk and tape. Now, some people say, well, Andrew, you've got to learn to settle down, take your medication, center yourself. And I will do so. Wow, that's a mistake. I should have said RCP. But every time I want to do that, every time I want to trust a little, I get screwed. RCP, for example. RCP to a full file system on the other side returns, I did that correctly. Furthermore, the file is the correct length. It actually seeks to the end of the file to give it the correct length. Bastard behavior. It's just annoying. But anyway, so things like that. And how long has RCP been around? 20 years? Fine. Early Riser FS, before I realized the error of my ways, I tried Riser FS. You know, you could boot that thing and damn it, if you looked in the logs, there's like hundreds of lines saying, this is wrong, this is inconsistent, there's errors in this bitmap and that, and it would happily mount and just go on. You know, it's like, eek. I want things to stop when there are errors. And finally, I've already told you about iSCSI. You know, it's just disappointing that if things are going wrong, the first time you know about it is like the next time you reboot, and the thing won't mount because it managed to scrog, you know, sort of either the super block or something like that. I've had people try interventions with me. Now, I was, I know this is going to sound odd, but, you know, I live in an odd environment. I was swapping tape software implementation details with someone who apparently does this for his life's joy. It's a sad comment, but nevertheless. And we talked about what we did and stuff, and he said I was being paranoid. So I countered with the obvious. Well, how often do you check the value of close after you've written the tape? Now, you may think, well, this is an odd thing to say, Andrew, and let me tell you what the problem is. Modern tape drives are streaming tape drives. Things are buffered. The final I/O to the tape happens as you close the device. That's when the buffers get flushed. So in fact, even if the driver was doing the right thing, if there was an error on the last I/O, the close is where it gets reported. And this guy said, well, of course I would check close. And I said, really? No one in Unix checks closes. And, you know, he came back a day later, I got this shy email saying, I don't, but I do now. So much for that intervention. So I then started to investigate some of these corruptions I was seeing. So this is one, it's a 100 megabyte file. And you can see some stuff there. All of it, in this particular case, there are 7 areas of diff. This is a special diff program I had someone write for me that let me know about, in a sort of an ordered sense of a way, what the differences are between these programs. And you'll see that, in fact, we seem to have lots of errors that are mostly of the order of 16K long. They're all on 124-byte boundaries, which sort of smells a little of file system, because that's the page size of the kernel. And, but it's not substituting zeros. It seems like it's just getting random, you know, arbitrary data that doesn't belong to it. So that's sort of one case. I have no idea what to do about this. This one just scares me because it implicates the general buffer pool management or page management within Linux. This one's a little bit different. Here we have a number of things, although the last, this may actually be a single error, because if you notice, if you add up the links, the offsets in the start of the next one are roughly coincident. There are little gaps there of a few tens of bytes. And all the data that's been put in the new copy is all zeros. So there's something there that's splattering zeros all over the landscape. Or if you like, it's substituted in roughly 128 Ks worth of zeros with a splattering of non-zero bytes. And I don't know how to interpret this one either. I used to have an intuition about these things, but these things puzzle me deeply. Now, everyone said I'm just paranoid, and I've accepted that rubric for a long time. But now there's, I have friends. Alan Cox recently made a post after someone asked about all the different places that in the Linux kernel that you can get errors that aren't reported on your data. And it's driver specific, but there are just a whole bunch of stuff where it has the opportunity to detect errors and doesn't, and it doesn't report them. You can go look that up. By the way, this, the slides and therefore these URLs will be available at some USENIX thing I've been told to send them to USENIX, so I'm sure they'll appear somewhere. Or you can just Google it. And then we came across a CERN paper where they talked about data errors on their servers. And in fact, they looked at both the issue of memory errors and storage errors. They did storage errors mainly in the idea of like writing test files out there and detecting that they got them back. So they're not measuring long-term decay or anything like that. And they found a significant number of errors. Now, it turns out that it was actually about a third of that if you look at the specs of the storage devices. But there was still a bunch of uncorrected, real errors. They wrote out X, they got back Y. And you can look at that, and that's from February of this year. And I'll finish with a quote, at least in this part, with a quote from Bill Bauer, who's a bigwig in the ZFS world, who said this: his disk capacities are doubling, but the bit error rate has been relatively constant. One uncorrectable error every 10 to 20 terabytes, which actually corresponds to what I've sort of been observing. I haven't done any real formal studies, but anecdotally, when I look at the things that have been going on in our systems, I would actually say of the order about once every 10 terabyte years, you get a file that gets changed. This is a static file that's just sitting there in a file system. Its contents change. Now, I'd like to say let's put this all in perspective, but you can't. I think, I don't know how to put this into proportion for you. The problem is that these are small errors and small error rates, but you are on a curve, and your users are going to force you onto a curve where you are running up into this where it's no longer going to be incidental. You have to have a strategy to deal with it. Now, of course, I have a theory about that. Disks are thin at one end, much, much thicker in the middle, and thin again at the other end. What, there's no Monty Python people here, for heaven's sakes? But don't worry, be happy. Disk is cheap. Your life is easier. I think supporting lots of disk is non-trivial, but it's manageable. We've talked about some of the traps. You really have to be careful about size of file systems. In my world, I've just given up on ext3 because I can't manage 300 gigabyte file systems. I have too many of them. And you can't make them bigger than that, otherwise your downtime is going to be hit with random 45-minute FSCKs. So I've gone over to XFS and now roughly partitioned my file systems out in 5 terabyte sizes, which gives me a manageable number of them. And an XFS is quicker to come back up too, of the order of 10 seconds, 5 seconds. And like I said, the issue of uncorrectable and undetected errors in your files, and I want to stress this, even when you don't do anything to them, is real and measurable. And if you've only got a couple of 100 gigabytes, you may not see it. You might see it every 2 or 3 years, in which case maybe you don't care. But if you've really started to get petabytes, hundreds of terabytes, you will see handfuls or multitudes of this per year. You need a way of addressing that. You really, really do. And I think I'll end on that note. I'm certainly happy to take questions.
I'll ask a question. So do you just back all this up by duplicating your entire system with another one and mirroring it?
Well, I run my data manager service within Ngawi. I always have 2 copies. And that means I have two copies. And the nice thing is that when one copy changes its checksum, the data manager just says, oops, I only have 1 copy. I'll just make another one.
So is there going to be some common mode failure someday that will give us a really, really bad day? Ngawi will be gone?
You know, if you have a really bad day, you might have an issue unless the stuff's on tape. Now, stuff on tape, I really check, and I've actually not seen files change while they're on tape. So for now, I view tape as a far more trustworthy medium. However, I will point out that I deal with tape in a rather different way than most people. You might be able to guess how it's different, but basically I write stuff onto tape. Every little segment you write onto tape has got a header in it. There are checksums galore, and I only consider a file to be on tape when, after the entire tape is written, I go back and reread the tape, verifying all the checksums.
On a different drive.
On a different drive. And only then do I acknowledge that I even have put the file onto tape. That's how I work, and that's why I'm pretty sure that when I say something's on tape, and I always put it on tape twice. You know, when I say it's on tape, I really mean it's on tape. And it's not like I just threw it there and hoped. Yes, sir?
Given ZFS seems to aim to solve most of the problems you've got, can you talk a bit about your usage of that and what testing you've done?
We don't have any sons, per se, so it's hard for us to test ZFS right now. ZFS actually has explicit support for this. They understand this, and they do it at the right level, which is just before it hits the users. So I'm actually sort of really hopeful that ZFS will take most of this pain away. The bottom line is, though, that you know, shops are going to have to deal with large amounts of storage on things that aren't ZFS. So, you know, I think ZFS is just a great idea. They do end-to-end nearly as far as you can do it. There's maybe one, so I hate to resort to old anecdotes, but there's one sort of case that worries me deeply, even if I trust the file system. And again, this is an old anecdote, 10 years old, and I'm sure Linux is better now. But I did the following scenario. I did basically the following thing. I said gzip less than, gzip minus d, or whatever decompress is. So let's say gunzip, less than thing.gz, pipe to wc. And I just did that. And you get an answer. That's fine. You do 10 of them. All works just fine. I did 100. Guess what I got? I got 10 saying, gzip, import in incorrect format. And I'm thinking, the same file. And you know, the only thing I can think of is that the kernel routed the wrong blocks to gzip. Right? That's the only thing I can think of. The file's not changing. Everyone else is happy. It's the kind of case where you want it to fail 100% of the time or succeed 100% of the time. This intermediate result is really not useful. And so that's a case where even a kernel can just screw you over, even if the file system was delivering the right bits. So anyway, to get back to your point, I think ZFS is a huge step in the right direction. They checksum everything. They do end-to-end, which is great. I still think you need, if you're going to like tape or permanent storage, you really want, I think you as a user ought to have some kind of independent corroboration of the contents. And by the way, I know I didn't say it, but for my corroboration, I use 256-bit MD5 checksums. And I know there's, at least amongst the cognoscenti, there is dubiousness about whether or not you should use these cryptographic hashes as a way of measuring what a file's contents is, but for now, this seems a fine thing. But anyway, yes, I think that's a great idea, but it's not going to cover any significant part of the world for a while.
Thank you.
Last time I checked, tapes were only good for about 10 years before the oxide started to fall off.
That's your old, I think that's your father's tape. Tape is actually much better than that now.
Has this changed?
You know, they have better binders, they have better bases, they have better formulations. They change the formulation every time they jump the density. You know, I think the stuff is much better than that now. Even so, my rule of thumb is that every second generation of tape, you recopy all your tapes anyway. I mean, the speed is, even if you steadily increase the amount of stuff you have on tape, the speed doubles every generation, the density doubles. So essentially, you take all of the stuff, you copy it onto the new media.
So
I think you have
that's-
more of a problem with the drive.
That's every 5 years, say?
Well, I think you can probably do it every 10 years. I've not seen the tapes go bad yet, but I don't have 10-year-old tapes. I have 5-year-old tapes and 3-year-old tapes that I've pounded on. But I've just not seen any errors on them, and I have 2 of them. But anyway, the problem is that I don't think the drives start going out of warranty and service and stuff before the media. Right, this is serious. I think the hardware drives actually go out of favor faster than the media does. It was certainly true of us when we had an Ampex based tape system. The drives went bad, and we had a limited period to copy all the stuff off the tapes because the drives at that point were $75,000 each. So it wasn't something we wanted to fool around with. Adam.
Last year you mentioned having to do consistency checks after RAID rebuilds. Are you still doing that, and do you have any more data from what you had last year?
No, we haven't done that systematically. We've done it on a sporadic basis. Every now and then I will go and invalidate all the checksums for the files on a system and rebuild them all and look for changes. And that is what's leaving me to confirm this figure of roughly every 10 terabyte years you start losing some. But they occur in patches sometimes. And again, I have no explanation for what's going on there. Normally I have a good intuition for how to interpret these sort of error bursts, but these have got me fooled right now, other than the fact that the page-aligned ones really seem to be page issues within the OS. But this is a very hard area. It happens very infrequently, and I'm at a loss as how I'm supposed to report this to the Linux kernel people, saying, sometime in the last 6 months, something happened. Go on.
I was wondering if the errors and problems you see, if this is just on the server side, or does this also include things like disk-based backup, things like data domain, devices like that?
No, these are all in direct attach RAIDs to a Dell server or something like that. So really the data path is program memory. Well, actually, the program path is is memory through a fiber channel HBA to the RAID. Now, I will point out that the reason why we know these things change was that after they got to the RAID, we checksummed them. Like minutes later, so there should have been ample opportunity for everything to be flushed. We checksummed them back off the RAID, and then when we went back a month or 2 later, we checksummed them again, we got a different answer. So I think it's fairly clear it's the RAID that changed, the bits on the RAID. It wasn't like they got there damaged. And I don't, it might be the RAID, but it might be the RAID. But it seems unlikely with that sort of thing. I don't see huge bursts of errors, 16K long, happening. It could be. What do we know? RAIDs are complicated beasts. Despite their apparent simplicity, they're quite complicated bits of code. And so, and that's something that I really wanted to, something I've been floating around at the last Hot OS I was at, was that when we talk about error rates of storage devices, we have a lot of manufacturers, RAID units, disk vendors, will give you an error rate in terms of bits, how many bits per, what fraction of, how many bits do we expect to read or write before we get an undetectable error or an uncorrectable error. I think we actually should start talking about the error rate of OSs, or of OSs file system combinations. And it may well just be, and again, this is hypothetical, I'm not making any claim here, that a combination of this style RAID and Linux has an error rate of, say, 1 in 10 to the 12 bytes per year. And just leave it at that. That's the error rate you get by running software. And I think expressing it as a proportion like that makes people just more aware that when you start running huge numbers of bytes through these things, you're going to start seeing errors, and that's just the way life is. I don't think anyone claims that OSs are perfect or error-free, do they? Hands up? No? Good. So you have to factor that into examples. And I've got to tell you, in general, users will never, ever notice. This is the one constant that I've had, is that no one ever sees these things unless you look for them. And as far as I can tell, no one looks for them, pretty much. So hats off to ZFS for actually doing that. Okay. Thank you. Mark.
Andrew, is there any reason why you discount memory errors for these discrepancies?
Well, memory errors where? In the server?
RAM, yeah.
That never explains why we get consistent results on reading. Like if we write one set of contents, it's there and we can checksum it and read it back, checksum and read it back. And suddenly over a period of 2 months, if we go do that again, we suddenly get the same different answer all the time.
Okay.
Then it doesn't smell like memory.
Okay, thanks.
And memory, and it also doesn't smell like memory in the sense I don't expect that to be page aligned or to have things like everything gets set to zeros. These are, again, not really indicative of memory. That you would expect more like single byte errors or 32, like a hash line, cache line errors. So, memory errors are an issue, and I point out that actually most systems do not use ECC, even if they've got ECC. They turn ECC off most of the time. So no one would know they're having ECC errors anyway. No, these don't seem indicative of that.
Okay, thanks.
Okay?
Thank you, Andrew.